All right, let's continue with warm-up number 1. So we're on to question number 6. And for question number 6, we have rectangle ABCD. A, B, C, D. And we know that the perimeter of ABCD is 34 and AB is equal to 5. So if AB is 5, CD is 5, and I'm sorry, the question is, what is the perimeter of triangle ABD? So if we know that AB is 5, then CD has to be 5. And if we know that the perimeter of ABCD is 34, then that means 34 minus 10 is 24. 24 divided by 2 is 12, because these sides have to be equal. So now I know two sides of ABD. I know AB is 5 and AD is 12. So what I'm looking for is ABD. But because this is a triangle, I can use the Pythagorean theorem. Boy, I can't talk today. The Pythagorean theorem. And that says that a squared plus b squared is equal to c squared. So in this case, a squared Okay, so the Pythagorean theorem says that a squared plus b squared is equal to c squared. So let's call this side A, and we'll make this little a. This side B, so this is C. So that means that for our triangle, 5 squared plus 12 squared is equal to c squared. So 25 plus 144 is equal to c squared. And 25 plus 144 is 169 is equal to c squared. And if I take the square root of both sides, I get c is equal to 13. Now here's the thing, you might think, okay, so the answer is 13. No, that wasn't the question. The question was, what's the perimeter of triangle ABD? So that's going to be equal to 5 plus 12 plus 13, which is 30. And that's the answer. Now let's go on to number 7. Number 7, Harvey has a fair 8-sided die that has a different number from 1 to 8. On each side. If he rolls this die twice, what is the probability that the second number rolled is greater than or equal to the first number? Okay, so if we have an 8-sided die, you know what I mean. If we have 8 sides and we're rolling it twice, then that means that we have 8 times 8 equals 64 combinations of 2 rolls. Because there's 8 choices for the first roll and 8 choices for the second roll, and then you multiply those together and we get 64. So that means our result is going to be a fraction where the denominator is 64. because that's the total possibilities. And so our question is, what's the probability that the second roll is going to be greater than or equal to the first? So you figure our first roll is either going to be 1, 2, 3, 4, 5, 6, 7, or 8. So if I roll an 8, so this is my first roll. So if I roll a 1, how many different numbers or possibilities are there on my die that could be greater than or equal to 1? Well, all of them. So I've got 8 possibilities there, and on 2, I've only got 7, because if I roll a 1, that wouldn't work. And so it just keeps going that way. So what I'm saying here is that if my first roll is this top number, then I have 8 chances that my second roll can fit our criteria. If my first roll is 2, 7 chances that my second roll is greater than or equal to 2. If I roll a 3, 6 chances that it could be greater than or equal to 3. So now if I add all of these up, this second line, eight plus 7 is 15, plus 6 is 21, plus 5 is 26, 30, 33, 35, 36. That's going to be my numerator. So I have 36 in 64 chances that my second roll is going to be greater than or equal to my first roll. And so then I can just reduce this and make that, let's see, they're both divisible by 4. So I can make that 9 over 16. And that's my answer. I'll tell you a quick shortcut. Anytime you have to add up a string of numbers like this, you can take your last number and call that n. And so if you say n times n plus 1 divided by 2, you're going to get the same result. So in this case, we've got 8 times 8 plus 1 divided by 2 is equal to 8 times 9 over 2, or 72 over 2, and that is 36. Number 8. In scientific notation, what is the product of 1.2 times 10 to the third and 1.4 times 10 squared? And we're going to express the number in 2 significant figures. So a simple way to do this is going to be, because we're multiplying these together, because that's this product, right? Yeah, we want the product. So we can just say that this is 1.2 times 1.4 times 10 to the third times 10 squared. So 1.2 times 1.4, it's just 12 times 14, right? So this is going to be 1.68 times 10 to the third times 10 squared, or 1.68 times 10 to the fifth. And because this is scientific notation, we're going to leave our 10 to the fifth. And I don't know if I said it. I got 10 to the fifth because I just added the exponent since it's multiplication. But the problem asked us for 2 significant digits, so I'm going to make this 1.7 times 10 to the fifth. And that's my answer. Number 9. When the integer n is squared, the result is, well, the result is less than, the result is less than 150. What is the sum of all possible values of n? Let's see. Well, we know that 12 squared equals 144 and 13 squared is 169. So that means n is less than or equal to 12 because this won't work. This is too high. And remember that trick that we talked about up here? We can use that again because the question is, what is the sum of all possible values of n? So this would be 1 plus 2 plus 3 and so on. So we're going to take 12 times 13 divided by 2 and that's 156 divided by 2 is 78. Doggone it. Trick question. This is not correct because the question said integer. So if these are integers, not just 1, 2, 3, 4, and so on would work. -1, -2, -3, and so on work. So that means they all are going to cancel out, so our answer will be 0. So I apologize for that. This would have only worked, 78 would have only been correct if they had said non-negative integers. But they did not. So the real key on this one was making sure that you understand the definition of an integer. All right, last one, I'll squeeze it in up here. Minnie paid a one-time registration fee of $30 for dance lessons. Additionally, she paid $20 per lesson. If she took 7 lessons, how much did she pay altogether? Well, she paid 20 times 7 plus 30. So that's 140 plus 30 is 170. So 170 is our answer. So that is it for warm-up number 1. Not too terrible, but a couple little tricky